How's it going, everyone? Welcome, Olier Gonzalez here. And today let's going to finally is dive deep into the philosophy of coercion, the example of coercion, and how do we get here as a way to move on to the next topic, which is equality, right? So the TLDR of this course is to understand what are the three pillars of JavaScript, which is according to Kyle Simpson's serious book, right? That you don't know GS is a type system and anything related to that, right? So in there we have is stuff like the primitive, the object, what it is, the corner cases, as well as some special values such as positive and negative zeros, nan, what actually represent those primitive or values, and understand the type of emptiness, which is undefined, undeclared, and uh, uninitialized, all right? And then now understand with this foundation is the next topic, which is the abstract operation, these conceptual algorithms that happens at the language level we cannot have access to. So anytime that JavaScript evaluate an statement, all right, or an expression, okay. So, but most likely an expression, because expression, unlike a statement, is produced now an action call. An expression is a produce a value. So anytime that JavaScript is trying to determine is the type of this value, all right, it's gonna do this abstract operation. There's several of them. We're gonna focus our attention on these three main common, because once we understand this, we're not going to embrace one of the flaw of this JavaScript that a lot of people say it is type nature, it is type coercion, and so on and so forth. Okay, so now because of that, the toPrimitive is one of them when we look that is trying to now coerce or to transform that value into a primitive like a string or number or undefined, null, yada yada yada, right? So this primitive, the toPrimitive, is trying to coerce that, whether it's on a string or a number, based on a hint that is passed internally by the language. Okay, so if this is if the hint is a string, I'm going to perform now is what I'm gonna call is internally these methods like toString and then the toValue or value of. If it's a number, I'm going to call that in a reverse order. So, but the thing here is that even though it didn't find, if the output of this two primitive is not an primitive, it's gonna recursively call that until we have and find that primitive value. Okay. So when you look now at the toString, which is the stringifications of values, all right, whether it's a stringification of numbers, when you pass now a positive number, it transforms that into a string number, or a negative number, it transforms that into a negative number, or anytime you want to stringify a primitive, whether it's undefined, number, boolean, is going to now stringify that properly, all right. The same is for numbers. There's some corner cases like that, especially with zero, where now it coheres that into there's some corner cases. You're gonna find that out, and I'm gonna dive deep into that. But there's some corner cases. The other is when you try to coerce or transform is an object into a string. That's what you have now, object. And the other is the an array, which is kind of weird behavior here. So when you have an array and try to stringify that, it is an empty string. If you want to try to stringify is the null or undefined, and I'll give you now a comma for that. If you try to stringify is an array of numbers, it gives you now is the values inside of that. If you try to stringify is now a how do you call it, an object, something that I mentioned before, we know that. And when you try to numberification, or in other words is the toNumber, transform that value into a number. If this is a string, it has a particular algorithm that it follows. All right. So if you have now is a string is a 0 or a -0, it actually converts that into. So let me actually show you this, so you can see that I'm not talking. I'm not saying BS. Okay. For example, like this. And here on the console we say, hey, the numberification of a empty, is on an empty string is 0. This is when now empty strings become is the root of all evil in JavaScript. All right. If this is of course not an object, it is nan. If you pass now a representation of a another numeric system, it actually trying to convert that, which is great. But what about now with true or Boolean values, right? Pretty straightforward. True is transformed to 1, false is transformed to 0, null is transformed to 0, and undefined is transformed to an n here. All right, give me a second, I'll be right back. And we're back. So with that overview of the numberification of the numberification of strings, and then now with objects, and then with arrays, for example like this or this, okay, or a nan, okay. Now the other is the Boolean, which is the two Boolean abstract operation, which is a lookup table, right? So as long as you memorize is the falsy values, it'll be good. So anything that is a null, undefined, 0, nan, empty string is a false is a false value. However, because we also look at some of the corner cases with the coercion, where the idea of this is to create a mental model, have a mental model to be descriptive when it is needed about the intention of this particular value and why we want to do that and when we want to do that. All right, by exploring those corner cases, which is something that most of the time with numbers, all right, and also Booleans, in the corner cases with the comparison, all right, that I think that comparison is something that shouldn't has been happen in the first place, but in any case, the thing is that understand that when you're going to deal with a particular language, any language, you have to deal with this type of values. So it's things that you can store in memory and what those represent, right? So one of the things of these abstract operations here is that, for example, in JavaScript, by being implicit with this, sometimes it is useful for as a developer. So, for example, boxing, which is something that JavaScript does anytime that it evaluates when you're trying to access to a property of a variable, all right? What it does is to temporarily wrap that into an object so you can have access to that property and methods from that type of values. So this is an implicit coercion or an implicit operations that when we talk about the philosophy of coercion, which is something that a lot of people actually describe that as a flaw in JavaScript. No, that's a flawed design, right? Or when you need to show is um, this intrinsic nature of the language to junior developers, and you try to avoid that. No, 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 don't think about it. It's like, no, they don't care. I rely only on triple equal. Both of them are approach that are not effective in terms of being able to build these applications, be able to develop that, and ship features fast, and also is with the bug fix when they happen. So the idea is to promote a culture of learning by looking is at how your language work, especially those areas in which you're not familiar, you want to intentionally avoid because you think that you can now squeeze around about that and use this particular tool if it's needed. The idea is that I don't care where you are, I care where is your direction. And this is also something that not from you, if you're a senior or a technical program, or any of those roles, right? But also for yourself, is like, where is your directions as a developer that you want to dive into this? What is the industry? Where is the area that you want to go with? And I think this is more for a philosophical, and I know that this is encompass this philosophy of coercion, as well as the intentional coercions, why we need to be more intention about the code that we want to write. In other words, is the intentions of the type coercion here. So it'll be much more better to deal, for example, is with strings and numbers, or handle those edge cases with string and number, as well as the corner case, right? So by looking at the being explicit or intentional coercion, and also with the culture of learning that is around of everything that is in JavaScript or in this beautiful world of development, in that the coding in itself is a form of communication, and the more effective way you are, the better off will be for your future self and others, right? So with the distinction of the code, what does the code, what is the code express, which what it does or how it does the stuff, and the common express now is why we're doing this, all right? So a final word on this implicit coercion is that you don't necessarily, there is a famous word from Doug, Crawford. So he is famous for the book he wrote in 2008, The Good Part, all right, and also the designer of the JSONs, the holy moly, all right, so somebody that has experience on that field. When he says that if a feature is sometimes useful and sometimes dangerous, and if there is a better option, then always use the better option. So define, this is in the abstract, okay, use, but in concrete is not useful. So this is something that now Kyle Simpson mentioned here, and it says useful, dangerous, and better. What does it mean, each one of those words? Useful in the context of software developers is that it allows us to focus on what is important. And dangerous is when we don't know the expected output of this. And better is that something that improves the reader of the code. So anytime, so, or in other words, so yeah, and the TLDR of this is, now since we want to, so it is neglected, and it is irresponsible, knowingly, to not only avoid uses of features that can improve the readability of our code, so we can focus on the things that really matter. Now, with that, then let's take a look at the piece of code where we're going to focus in this video. All right, so we can move on to the next topic. So we look at the coercion, and here we are in the coercion. We're going to define is two functions here. Follow me along here. I think it is. No. I think it's this one. Where is? There you got it. All right, and here we are. Now, okay, here we are. So, the point of this is of this exercise, of this coercion, the philosophy of coercion, is say, in this exercise you will define some validation function to check out user input, which is something that a lot of the time we want to do. And if you're going to, for example, go and apply to a particular company, and if you say, hey, I want to go out with React for this React role, I want to get into this, a lot of the time they're going to tell you, hey, this is what you that you must know about it, right? How to handle this user input with the form, and so on and so forth. Good. So check the user inputs, so such as from DOM elements, all right? And you will need to properly handle the coercion of the various value type. Good. So instruction: define an isValue name validator that takes one parameter, name, and the validator returns true. Okay. If all the following match the parameter, false otherwise. So it's going to define now is this with the following. Okay, validator takes one parameter, name, and the validator returns true if all of the following match the parameter, false otherwise. So it must be a string, must be non-empty, it must contain non-white space or at least 3 characters. So as a way to be very descriptive here, okay, we can say this is the name of the function, okay, that is going to receive name, and this is the kind of stuff that needs to be evaluated here, right? So we need to check if that is a string, okay? So we say, hey, if the name, which is if the type of name, which give us a string, a set of string, and we can use this the double equal here because we are sure that this is going to return now a string and no corner cases, okay? If this is a string, all right, well, we also want to now check that must be a non-empty. So, well, I also want to check that this is not a non-empty, all right, which means is that we have something in there, okay, we have something in there, and must contain non-white space or of at least 3 characters. So what we can do here is that, well, name.trim, that I want to remove the leading or the trailing white space and line terminators, okay? Since this is now a boxing, what's happening here is this is boxing. Why is that? Is, well, no, Java, so we know that this is a string type, and therefore we have this type of operations. So what we can say is if the length, okay, if the name.length is greater than 3, or we can say something like this. Let me trim that. Let me trim that. All right. Now that I have that trim, so I remove all of those white space, trailing and leading, the leading and trailing white space. Now I want to get the length of that. All right. So far so good. if this actually match all of this, then we can say, hey, return true. Otherwise, return false. Okay, if we want to make sure that this actually will work, we can say, hey, as a way to make this actually work as expected and don't give us any error, we want is to now run this. Okay, type exercise and say coersion, right? ls. We are now here, and I want to say no, please. I'm gonna run this exercise file, and we're supposed to get is true for only those functions that run as expected, right? So it's valid name, it is true, all right. The other is it's valid false. So it is here. We skip now 4. 1, 2, 3, 4. So 1, 2, 3, 4. We skip that true. Okay, it's valid name false is equal to false. False is valid name null is equal to false, right? This is true because we're passing now a null. A primitive is going to validate now as a false, and false or false give it to false. The same for undefined. The same for empty string. All right. It's going to now evaluate is this space character here, which is supposed to now give us is this. This is a very interesting question here of what's going on here. When you say, hey, node, what is the string value of this? You know, it actually remove everything. If you have a special character in there, it's going to remove that. That's interesting. All right, and it's valid here. It will say this is true. Okay. Therefore, is valid name X. So for example, like this, it evaluate that is valid name X. It's gonna pass here and say, hey, yes, the type of X, it is a string, but it's not a valid string because at least must have is 3 characters length. So this must be false, and then you got it, right? So that was straightforward from our string validations. What about now the other one? Define an hours attend validator that takes 2 parameters, which is the attendee and length. So we know that this is the property that we're going to receive. The attendee okay. The attendee, the attended, and the length, all right. The validator returns true if all of the following match the 2 parameters. Okay, the validator returns true if all of the following match the 2 parameters. False, otherwise. So let's go to look at that. So either parameter may only be a string or a number. Okay, so the parameter must be either a string or a number. Both parameters should be treated as numbers. Okay, both numbers must be 0 or higher. Both numbers must be whole numbers, and a 10 must be here. So either parameter may only be a string or a number. So here we're saying attendee must be a type of, okay, either parameter may only be a string or a number. All right, both parameters should be treated as numbers. So if you can say, hey, if this is now a string, all right, or in this case, or type attendee or string, type of the length, all right, is equal to a string if any one of them are a string. Okay, we're going to now say this one, right? So this is good. All right, we're gonna say, hey, if the type of attendee is a string or a string, either parameter may only be a string or a number. Okay, so we can do something like this. Exactly. If the attendant is now a string or a number, okay? So the idea here is that check if both of things are the same, okay? Check if both of them are a string or a number, and say that the type of length is equal to string or a number, okay? Whether this is a string or a number, now we have to make sure to convert that into a number. You know, both parameters should be treated as number. So in other words, it's like I want to convert that into a number, right? So attendee here, this is how you can coerce that into a number. Or number, then length, all right? If now once you coerce that into a number and it's true, all right, which is a valid number, both number must be 0 or higher. So in other words, we say, and both number must be 0 or higher. So once we pass this check by saying is the attendee must be greater or equal, both must be 0 or higher, or 0, like that. Attendee and exactly both number must be like that. So here's both parameters should be treated as number. Okay, so both parameters should be treated as numbers. Attending both parameters must be higher. Both parameters must be higher of that. So attending and length must be equal or higher than 0, and also we want is to now verify that this is whole numbers. So the number constructor actually have this convenient function for us, which say the is integer of the attendee and number is integer of the length, all right? And attendee must be less than or equal to length. And here we say attendee must be greater, must be less or equal than the attendee, than the length. Okay? Only then is when you can say, all right, it makes sense to now return true. Otherwise, return false. If we now execute this code here, if we execute this code, attendee and length. All right. Okay.
Okay, well, now, you could simplify. Then let's go ahead and try to make it into a number. So here we go.
So this is kind of the thing that we want to check here, right? This is kind of the thing that we want to check here. So we want to check if this is a string. Okay. So we want to check if this is a string. All right. We want to check if this is a string. This is also our other conditions. We want to check that this is a string. So yeah, we want to check that. We want to check is that, hey, this is now either parameter, maybe a string or a number. So we can say type of a string, right? And not only that, that we don't want to be here as an empty string. So we can say attended is different to an empty string. After we trim them, okay. All right. So now that we know that the attending, okay, is a number, we can coerce that into a number. We can repeat the same operation by saying, hey, type of now with the length, okay, is a string, and also the length after we remove leading and trailing white space is now different from an empty string. Okay, so we can now make sure that the length is equal to a number, or in other words, we want to coerce that. This is a statement here, the difference between a statement and an expression. You say, hey, the number here is to say length. Okay, I want to now transform the type of this. We can also create a new state from that if we do that in a programming style. Okay, so how can we do that? By saying it's like, hey, I want to now create a copy of this, attended copy, okay, like that. So this is the attended copy. Similar for this length copy. All right. So we are not modifying is the reference here. In fact, we are creating this new spacing memory for both of them. And then we can say, okay, so both numbers must be 0 or higher. Right, so now that we have them, we can check if, hey, both numbers must be attendee copy must be 0 or higher, and the length copy must be 0 or higher. Okay, Not only that, but both number must be whole numbers. Now that we have them in the same type, we can work with them. In other words, we're saying is this. And okay. Both parameters should be treated as numbers, 0. Both numbers must be whole numbers. And both numbers must be whole numbers. So the number object instance has that property. To check that is integer, attend copy. Okay. And we want to check if the now integer, we want to check if that now the length copy, okay, both of them are integers, and a 10 must be less than 10 must be less than or equal to length, and attend copy must be length or equal to length copy. All right. So once that is done, okay, I can say return true. Otherwise, return false. So if we now evaluate this, oh, because exactly we defined it here, so what we can do is something like this. Attend copy is now a let, right? Similar for the let copy. You said length here. Okay. So why we are doing this is because we want to, in this particular scope, don't mess with any reference that we're receiving, right? It's the only thing that we're doing here. Yes, the trade-off is we are creating now more space in memory here. However, we can make sure that they go only live here, and by the time that this function is pop up out of the console, we get rid of that space in memory. Now, if we run this, we get all of this. So we are doing is this. So we are doing this is now the reason to explain here the comment here, right? This is when the comments here are useful. Okay, so you say now this is the attended, which is a string or a number. And the attendee, which can be a string or a number. Okay, similar for this, it can be now a string or a number, and returns a boolean. Right, it's going to return that boolean, a boolean, right? So we are creating a copy of the parameters. A copy of the parameter is created because, exactly, a copy of the parameter is created just to follow the functional approach. Okay, so that's what we're doing is this. And in fact, I think the most counterintuitive stuff was to try to coerce that and then work them in one single type, in one single data structure. So then we can now work on that. Especially with strings and arrays. Okay, that makes a lot of sense. That makes a lot of sense. Okay. So here we can say is, no, not at all. Git stash. All right. And then I want to create now a branch here with the coercion. Okay. And here now pull from the my stash, git stash pop. All right. This one, and now add this solution to coercion. Exactly. Solution to coercion. And you push this origin to main, particularly the coercion. And there you got it, right? So a new branch was created, and here we are. Solution to coercion, or you can say simply like this, a coercion. And this is the solution to coercion. Personal notes here. Exactly. And create now this PR for that. Good. So move on. You know, move on with the equality here. Okay, but the thing of this is that if you want to, this is one of the things that you learn a lot is by doing, not by theory, bro, not by theory. So you are going to now coerce this type. I think you are in an old version here, or you're looking at like an old version. Yeah, you're looking like an old version. Why? This one. This is the version. Exactly. So comments are a way to describe is why we're doing this, and the code communicates what it does and how it does it. Okay? Interesting. Very, very interesting here. Attend copy. We're trying to get rid of this. This is one of the reasons why functional programming that is declarative is preferred, because it indicates now to indicate the intention of the reader of the code to do that. And we're going to read a lot of code for sure, and be able to describe that. That's another important stuff. So let's get into now is this one, which is the equality. The equality.
As I've been making this case for coercion, one of the things that may have been floating in the back of your mind is, yeah, but the coercion problem that I have is not with the plus operator or an if statement. The big coercion problems that most people seem to have seem to center around equality checking. And the same message that I have for all of coercion is going to apply for coercive equality as well. But I want to dig specifically into some issues about the double equals versus triple equals, since this is really the place where most people focus their attention when they talk about coercion. In fact, most people haven't thought about coercion in any other place other than the double equals versus the triple equals. So it bears some
comparison
further dissection. So how many of you have heard before that the difference between double equals and triple equals is that double equals checks the value, so-called loose equality, and triple equals checks the value in the type, so-called strict equality. This is extremely common, and unfortunately, even though it sounds really good, It's not exactly the case. That's not exactly the difference. And it's not just a, an academic nuance here. The difference really changes our perspective on the utility, the purpose of these two mechanisms in our language. So I really think that if you're trying to understand your code, it's critical that you learn to think like JavaScript. That's sort of been the thesis going along.
Yeah.
And the same is true for double equals and triple equals. That just saying, well, it's sort of one seems to check the type and the other doesn't, that may get you by in some circumstances, but in other circumstances, it leads you to completely different conclusions. So consistent with everything else that we've done, let's look at the spec.
Let's take a look at this.
This is the spec for what is called abstract equality comparison, which is the double equals. And
let's take a look at this spec here. That's what it is, man. Abstract equality comparison. Good. Good. Oh my god. Here we are. Good. 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 Equality. Okay. So ECMAScript. The ECMAScript. The abstract operation in this here is equality. Equality expression. But equality operators. Again, this is the abstract operation that's happening here. The abstract operation here. Ordinary type to boolean to canonical to index. Testing and comparison operations. Testing and comparison operations. It is important, especially if you're going to write JavaScript code, to understand how JavaScript see the world. You know, how JavaScript, which is a collection of people that they agree to say this is the way we think we need to do this. Is array, is callable, is constructor, is extensible, testing and comparing object. Is less than, is loosely equal, and is strict equal. Operations on objects. Okay. Okay, operations on objects as well. And operations on iterator objects here. Interesting. But let's take a look at the testing here. Testing and comparing and comparison operation. Is array, is callable, is constructor, is extensible. Is string well formed Unicode, same type, same value 0, is less than, is loosely equal, and is strictly equal. Okay, is loosely equal and is strictly equal. Here we are. The abstract operation is loosely equal, takes an argument of the value and another value, okay, and returns either a normal completion container, a boolean, or throw completion. It provides the semantics for the double equal operator, and it performs the following step when called. The same type x and g is true, then, so if they have the same type is true, then return is strictly equal. If x is null and g is undefined, return true. If x, okay, if one of them is null or undefined, returns true. It's vice versa, return true. Note this step is replaced in section B3 6.2. If x is a number and g is a string, return is loosely equal, which say I'm going to coerce that. Okay, I'm going to coerce that the second operator to a number. If a string and a g is a number, return is loosely equal, and it's going to convert the first into a number. That's interesting, because when you want to do arithmetic operation like add plus operation, it's going to do now a string concatenation. It's preferred that. It's going to choose that first. However, you doing the loosely equal, okay, now it's going to coerce that into number. That's interesting. If x is big int and g is a string, then let the string to be big int. If n is undefined, return false. Return is loosely equal, then. If x is a string and g is a big int, return is loosely equal here. Which is gonna call this and check if this is loosely equal on, okay, it's loosely equal on this now, on the big int. This is the algorithm here. It's now swapping position. It's swapping argument position. Okay, so it becomes a big int and they're going to run. If the x is a boolean, return is loosely equal to number negated, okay, and if a boolean is that, is loosely equal to number. That's interesting. X is either a string, a number, a big int, or symbol, and if g is an object, return is loosely equal, and going to transform that object into a primitive. If x is an object and g is either a string, a number, a big int, or a symbol, return is loosely equal to primitive of that. If x is a big int and g is a number, or if x is a big number, or if x is a or if x is a number and g is a big int, then if x is not finite or g is not finite, return false. If those numbers belongs to the realm of real numbers, return true. Otherwise, return false. If same type of x and g is false, return false. If x is a number, then return the number equal here. The algorithm differs from the same value algorithm in its treatment of sign 0 and n. But this is what's going on behind here. This is the way how now JavaScript, oh my god, after all of this year, after all of this year, I'm getting into the weeds. I'm getting into this, bro. Loosely equal. If I do this in JavaScript, equality here. Okay, if the operand have the same time, they are compared as follow. It's because it has an algorithm. It has an algorithm. If you're not familiar with, I don't care. Okay, makes a lot of sense. Yeah, and a lot of people actually are now avoiding that. Operator checks whether its two operands are equal, returning a Boolean result. Check if the two operands are equal. Unlike the equality operator, the strict equality operator always considers operands of the different types to be different. Exactly. If they are of a different type, and if you read this, if they are the same type, is false. Exactly. So if they are the same type, that's interesting. It's calling the same type. So if you use the strict equality, it is interesting. If you use the strict equality, it's a, if they're the same type, this is false. But it returned me true. What the fuck? You have the same type, x and g is false. Exactly. If the same type, exactly. If this is false, all right, so it is false. All right. So it's checking is by their primitive. Makes a lot of sense. Even if it's an object. Even if this is an object. So for example, like this. Even if this is an object. I want you to evaluate this expression. But it's saying now this is false. However, look at this. If x is an object and g is an object, return true. Right? This is from the same type. And it's strictly equal. It's the abstract operation is strictly equal that takes both values and returns a boolean. It provides the semantic for the triple operator, and it performs the following step when called. If x is a number, then it's going to now return the equal, and otherwise return the same value number. Same value number. So in other words, if it's called same type and it say, hey, if x is an object and g is an object, return true. But for some reason here, if x is an object and g is an object, it's gonna return true. Okay, it's gonna call that. So if it's false, return false. But it's not false. If x is a number, in fact it returns true. If x is a number, then return the number equal. But it's not a number. And return same value number. And here's when it's gonna do this. The abstract operation same value number takes argument x, but not a number, and g, another language value, but not a number, and returns a boolean, and it performs the following step when called. If they are the same type, alright, if x is an object and it's an object, if true, if x is either null or undefined, return true. If it is a x being int, no. If it is a string, if it is a boolean, note all ECMAScript values are compared by identity. If x is g, return true. Otherwise, return false by identity. For expository purpose, some cases are handled separately within this algorithm, even if it is unnecessary to do so. The specification of what x is g means are detailed here. If x is g, identity. And here's when it comes with the identity here. In this specification, both specification values are compared for equality. When comparing for equality, values fall into one of the two categories. Values without identity are equal to other values without identity if all of their innate characteristics are the same. Characteristics such as the magnitude of an integer or length of a sequence, values without identity may be manifest without prior reference by fully describing their characteristic. In contrast, each value with identity is unique. Okay, each value with identity is unique and therefore only equal to itself. Who determined the identity here? Values with identity are like values without identity. Values with identity are like values without identity, but with an additional, unguessable, unchangeable, universally, unique characteristic called identity. Reference to existing values with identity cannot manifest simply by describing them, as the identity itself is indescribable. Instead, reference to these values must be explicitly passed from one place to another. Some values with identity are mutable and therefore can have their characteristic as their identity change in place, causing all holders of a value to observe the new characteristic. A value without identity is never to a value with identity. This is the rule here. A value without identity is never a value with identity. So from the perspective of this spec, the word is used to compare two values for equality, as in if bool is true, then and the word contains is used for search for a value inside little list using list using equality comparison, as if as in if list contains a record error such as error foo is true, then the specification identity of value determines the result of its comparison and is axiomatic in this specification. From the perspective of the ECMAScript language, language values are compared for equality using the same value abstract operation, and the abstract operation is transitively called. The algorithm of this comparison abstract operation determines language identity of ECMAScript values. Specification identity agree with language identity of all ECMAScript values except symbols, values produced by symbol 4, so they are unique. The ECMAScript language without specifications identity and without language identity are the ECMAScript values, language values without a specification identity and without language identity are undefined. So without they are without without a specification identity and without language identity are undefined. So they don't have identity, meaning there are a value without identity is never equal to a value with identity. So there are values without identity. Undefined, null, boolean, strings, numbers, big int. The ECMAScript language value with specifications, identity, and language identifications are symbols not produced by symbol 4 and objects. Symbol values produce symbol 4 and have a specification, identity, but not language. But they talk about here is the identity. Okay, two things here. A value without identity. Okay. This is what it is, fellas. Is this, bro? And also, okay, a value without identity, and the other is symbol values produced for, and the other is this. So undefined, null, booleans, string, numbers, and big ints are values without identity. An ECMAScript language value with a specification identity and language identity are symbols, aka symbols, aka symbols. The identity here, they are not the same. Symbol, okay, not produced by symbol 4 and objects. Not produced by symbol 4. If I say like symbol 1, say symbol, and then let symbol 2, symbol, and if I want to compare symbol 2 and symbol 1, reference error, can access lexical declaration. I think it's because I missed something. Lexical declaration. Symbol 2 before initialization. But objects, they are not identity. So they are not equaling identity. Okay, let's move on, bro.
If double equals only checks the value and triple equals checks the value in the type, then
This
why?
is abstract operation, abstract equality comparison. Abstract equality.
right up here at the very top of the algorithm.
The comparison x and where x produce true or false values each comparison. Abstract equality comparison, but I think they changed that because now it is the same value type, same type value here. Is loosely equal and is strictly equal.
The very first thing are the types of x and y checked. Immediately we can debunk the myth that the difference between these two is whether the types are the same. That isn't very first equals. One seems to check the type and the other doesn't. That may get you by in some circumstances, but in other circumstances it leads you to completely different conclusions. So consistent with everything else that we've done, let's look at the spec. This is the spec for what is called abstract equality comparison, which is the double equals. And if double equals only checks the value and triple equals checks the value in the type comparison, which is the double equals. And if double equals only checks the value and triple equals checks the value in the type, then why right up here at the very top of the algorithm, the very first thing are the types of x and y checked. Immediately we can debunk the myth that the difference between these two is whether the types are the same. That isn't the difference. They both check the types. It's just that one does something different with that information than the other. Okay? So number one, the source of truth is always the spec, as we keep saying. And if you choose to persist in not completely correct mental models that seem to work in some scenarios, eventually, the longer the time span goes, eventually you'll run into a case where you're in a different scenario, your mental model is busted, and now you're
Double
lost.
and triple equals.
I think it's better to have the correct mental model. Just like the other places of the spec that I have cited for you, this is an algorithm with if statements and then statements and variables and operations. So it's something that you as a developer can understand. The vast majority of JavaScript developers have never once read this section. All they've ever heard about the double equals is what is said online about double equals and in books about double equals, which is almost never citing what the spec talks about, but only citing some anecdotal evidence why they think it's worthy. So,
Abstract
reading
equality
the spec
comparison.
can be useful. For example, if I have a string Frank that I've assigned to one variable, and then I create another copy, essentially, that's what's happening on line 2. So now I have two strings, and if on line 7 I try to ask if those two are equal, like I am on line 7 and line 8, in both cases they are equal and checked. Double equals only checks the value and triple equals checks the value in the type, then why right up here at the very top of the algorithm, the very first thing are the types of x and y checked. Immediately we can debunk the myth that the difference between these two is whether the types are the same. That isn't the difference. They both check the types. It's just that one does something different with that information than the other. Okay? So number one, the source of truth is always the spec, as we keep saying. And if you choose to persist in not completely correct mental models that seem to work in some scenarios, eventually, the longer the time span goes, eventually you'll run into a case where you're in a different scenario, your mental model is busted, and now you're lost. I think it's better to have the correct mental model.
Yeah.
Just like the other places of the spec that I have cited for you, this is an algorithm with if statements and then statements and variables and operations. So it's something that you as a developer can understand. The vast majority of JavaScript developers have never once read this section. All they've ever heard about the double equals is what is said online about double equals and in books about double equals, which is almost never citing what the spec talks about, but only citing some anecdotal evidence why they think it's worthy. So, reading the spec can be useful. For example, if I have a string Frank that I've assigned to one variable, and then I create another copy, essentially, that's what's happening on line 2. So now I have two strings, and if on line 7 I try to ask if those two are equal, like I am on line 7 and line 8, in both cases they are equal. Because it turns out that when the types match, then they do the triple equals. The double equals and the triple equals are exactly identical when the types match. There is absolutely no difference. And the spec says so. Exactly. When the types match, do the triple equals. That's what I just highlighted for you. And we can see that in code. In any place where the value types already match. And by the way, as I said a bunch of times already, you should try to have the value types obvious, and ideally you should have them matching as much as possible. That doesn't mean you can never have coercion, but you shouldn't have lots of places where you're doing comparisons. You certainly shouldn't be doing equality comparisons and have absolutely no idea what the types are. It's interesting to me that many people seem to suggest that it is impossible for them to program and understand what types could be coming into this comparison. And I
That's
don't know how you can write
nonsense.
any algorithm without having some sense of, well, these are always numbers and these are always strings. How can you say, well, I have no idea. It could be an array, it could be null, it could be not. I have no idea what it could possibly be.
What the?
And even if you don't know, that doesn't mean that it has to stay that way. You can choose to redesign your code so that you've narrowed the surface area of places where those different kinds of types can
Because
interact,
it's checking the type.
can interweave with each other.
And if they have the
You've
same
narrowed those
type,
corner cases
it's going to
that
call the
exist
strict
with
type.
coercion. So I wouldn't write a function that could take null, undefined, string, number, object, array, and 14 other types, and then all compare them with a double equals. That's lunacy, right? But I would write a function that could take strings and numbers and compare them with a double equals, because there's a very known and small subset of potential corner cases.
Exactly. Here we are. That's right, fellas. Is this because the same type is doing that? Hey, if they are the same type and it's false, return false. Okay? This is what the same, even here. If the same type, if this is the same type, then return is true. And it's true, then return is a strict equal here. So it's a strict equal, it's going to return, if the same type is false, return false. Right? It's a strict equal. It is calling that as well. And this is the abstract equality that is no longer called equality. Okay? It's called now is loosely equal. The abstract is loosely equal. Okay, the abstract is loosely equal from the 2026 spec, right? Holy moly! So it is checking whether it's double. It is checking its type. It is checking its type. So if I have two values that I want to compare and I know for sure they are the same type, all right. Therefore, all right, I know what's gonna. So it's gonna check of the same type of values. Okay, and the same type has a lookup table. Same type is this. Hey, this is undefined. It's undefined. It's true. This is null. It's null. It's true. This is boolean. It's boolean. True. Number, big int, symbols, strings, object returns true for double equal. Okay, for double equal. So if they are the same type, yes. And that you get is this. And same type is just a lookup table, pretty much like the two-boolean. All right, pretty much like two-boolean, bro. Pretty much like two-boolean. Okay. Good, absolutely good. So you have now here the same type, and then the other is the abstract operation. Okay. And something important that I think this is important to actually understand this. If you're trying to understand your code, it's critical to learn to think like JavaScript. Okay. So here we are, all right. And then the code for that, or code example here.
Narrow those corner cases that exist with coercion. So I wouldn't write a function that could take null, undefined, string, number, object, array, and 14 other types, and then all compare them with a double equals. That's lunacy, right? But I would write a function that could take strings and numbers and compare them with a double equals, because there's a very known and small subset of potential corner cases to work around. And those are avoidable if you pay attention.
Completely.
So in the case where the types already match, double equals and triple equals are the same. So what is triple equals doing? So in the case where the types already match, double equals and triple equals are the same. So what is triple equals doing? Well, it's also checking the types. And if they're not the same, it's false. It doesn't matter what the values are. If the types are different, it doesn't do anything else. It sort of short circuits and says, if the types are different, there's no possible way that they could be equal. If you think about that with respect to what double equals is going to do, which we're going to look at in just a moment, essentially the real difference between strict equality and loose equality is whether or not we're going to allow any coercion to occur. So what is strict equality going to do if the types are the same? Well, it's going to return false if they're nans, because remember, it's supposed to lie about nans.
Exactly.
And it's going to return true if there's a -0, because it's supposed to lie about negative zeros. But it only does the lies if the types already match. Otherwise, it says false and it doesn't check anything at all. So maybe the more appropriate statement would be that they both check the types, one of them stops early and one of them doesn't. Or said a different way, the difference is whether we allow coercion. So here I have two objects, right? They have the same structure and ostensibly the same value, but they are not the same object. They are two different objects. A lot of times people get confused with JavaScript's built-in equality checking, that it's somehow not structural in nature, that it doesn't do like a deep assertion check that the structure of one object is exactly the same as the structure of another object. Maybe there are languages like that, but I don't know of that to be a prevailing thing that's built into an operator in a language. Most operators seem to do what JavaScript does, which is identity comparison. If Workshop 1 and Workshop 2 pointed at literally the same object reference, then their identity would be the same and you'd get true. But in this particular case, they're not equal. Okay? So neither double equals nor triple equals is going to return a true.
They're doing is this identity comparison. Line 9 in line 13. Exactly.
Two different objects. A lot of times people get confused with JavaScript's built-in equality checking, that it's somehow not structural in nature, that it doesn't do like a deep assertion check that the structure of one object is exactly the same as the structure of another object. Maybe there are languages like that, but I don't know of that to be a prevailing thing that's built into an operator in a language. Most operators seem to do what JavaScript does, which is identity comparison. If Workshop 1 and Workshop 2 pointed at literally the same object reference, then their identity would be the same and you'd get true. But in this particular case, they're not equal.
And this is interesting because exactly. Line 9 and 13 must be workshop 1. But this identity comparison, exactly. So the equality is based on the identity comparison, especially for objects. In other words, object reference pointing to the same space in memory. Equality in JavaScript for objects and for other languages is based on the identity comparison. In other words, objects reference pointing to the same space in memory. But this is the identity. Okay. Use a reference equality by default, double equal. But dot equals can be overridden for value equality. Compares value. Mm. Mm-hmm. You define what equals mean through operator overloading. Identity equality, same object in memory, and value equality, same content. JavaScript. This is the reason why we need to look at this is, and this distinction, value equality and identity equality. The triple equal. In other words, object reference pointing to the same space in memory. For value identity, we use double equal in objects. So for example, you have now the two objects that have the same, for that, the same value identity. Value identity, you say, hey, this is the name. Yeah, right. And I want to compare that for their value. It tells me that this is false. Okay, they are not the same. Even though that I'm trying to compare that with values, I count object 1, and then I say count object 2, and here I want to do something like this. Object 1 is equal to object 2. And it tells me that this is false. It's because it's checking, so it's telling you that I'm not gonna check this by their value. I'm going to check it by their identity. And holy moly, bro. Interesting. Even with triple equal, it say no, I'm not gonna compare that with that. So object dot is that's interesting. Makes sense because they are different space in memory. They have different space in memory. That's what I have. Okay, it has different space in memory. Exactly. They have different space in memory. So for example, if I do something like this, and I try to compare that, okay, so cons is working in this interesting way here. Holy moly. Okay.
Okay? So neither double equals nor triple equals is going to return a true because they are different objects. Everybody follow me? They're different objects. They are not the same. And so it doesn't matter which one you use. You're still going to get the same result.
Exactly, because they're different in space in memory.
So in other words, the double equals is going to allow coercion when the types were different, and the triple equals is going to disallow coercion when the types are the same. And I would claim that just like every other operation, it is helpful if you understand what the types are. Like every other operation, you have to ask yourself, if I know the types, is coercion here helpful or not? Maybe it is helpful, maybe it isn't. It's a critical analysis. It shifts the discussion away from, oh, double equals is bad and unpredictable, to, do I want to allow a coercive comparison or do I not want to allow that? In this particular case, is it more helpful to me to do so, or is it less helpful? Is it more safe, or is it less safe? In other words, you need to be critical, analytical thinkers and look at your code and decide what you can know about your code and what you can't. And essentially, the decision about double equals and triple equals is a trailing indicator of whether you actually understand your program. Let me say that again.
Exactly.
Your choice to use triple equals is not just because some guy wrote in a book that you should always use triple equals. Your actual choice to use triple equals is a trailing indicator which points back to the fact that you don't know something about the types in that comparison. And so you have to protect yourself. And my opinion is, if at all possible, maybe it would be better to fix the root problem, which is that I don't know what the types are in this comparison. It's too unpredictable. It's too polymorphic.
It's too unpredictable.
That's going to lead to better code with fewer bugs, regardless of whether you use a double equals or a triple equals. Deciding what your types are, making it obvious what those are. So do we know those types? Let's take a look at what the double equals is going to do if the types are different. First off, if the types are null or undefined on either side, that's what these two clauses are paired to say. If x is null and y is undefined, or vice versa, then return true. In other words, the null value and the undefined value are coercively equal to each other and to no other values in the language, which is what clause 10 says. It says return false. Null and undefined will not match any other clauses in this algorithm other than clause 2 and 3, and so it's only coercive to each other. I find that to be a tremendously useful fact about JavaScript, because quite honestly, I don't like having two empty values. I find that to be confusing. So I would much rather deal with one empty value, and since null is shorter to type than undefined, I'd rather deal with null everywhere, and pretend as much as possible that undefined doesn't exist, or at least pretend that they're interchangeable. JavaScript does make some distinctions between them, such as the default value algorithm, but for the most part, you have the option of treating null and undefined as indistinguishable through coercive equality. So you could do a check like this. You could have a workshop 1 and a workshop 2, and there's a topic property on there. You could be asking of that topic property if it's been set and it's null, or if it's never been set at all, or if it's been set and it's too undefined. You could try to distinguish between those two, but I would argue in almost all cases, that's not a useful distinction. Whether the property was ever created and has been reset back to null, or whether it's been reset back to undefined, or whether it was never created at all, those are basically all the same condition, or at least I would argue that's a better way to code, to treat those as indistinguishable. So one option is for you to write what you do on lines 5 and 6, which is to use this triple equals that does not allow coercion and explicitly checks all of those cases. Explicitly checks that workshop1.topic is null or workshop1.topic is undefined, and the same thing is true of workshop 2 topic. Are you gaining anything readability-wise by being explicit here? Ask yourself the question if the reader is benefited from having to juggle in their head the distinction between two empty values. My assertion is that no, they are not benefited, and using the double equals like we do down here on lines 12 and 13 is far more clear. It says, whether they are null or undefined, tell me if they're empty or not. Tell me if they're one of those two empty values. And by the way, I just picked the shorter of the two because it's less the type.
Because it is treated like that.
This is an example of using coercive equality. And even some of the staunchest, harshest critics of coercion, you will find them using double equals null checks in their code, because it's less controversial than some of the other double equals usages. Most people seem to be okay with it, even though JSLint says no. Most other people have those linting rules turned on. I use ESLint. It's an amazingly configurable linter. I have a very different rule set than you do, I'm sure, because I have very different opinions. But I use an ESLint tool, and I turn on what rules help me write better code, and that's what linters are for. Linters are an opinion that helps you decide whether or not your code is formatted in such a way or structured in such a way to avoid bugs, or whether it's likely that a problem will occur. It's not checking if your program is correct. It's giving you an opinion on whether you've done the right thing. The thing about opinions is that everybody's got different opinions. So the best tools are the ones that are most configurable. Not just to individual opinions, but most effectively for teams. Let a team decide what is effective for them. To any extent that you use a tool that shares an opinion about your code with you, by way of erroring out your build process, to the extent that that tool is unable for you to configure it so that you can get your job done more effectively, and it forces you to change the way you code to adapt to it, then that tool is not helping you, it is hampering your development efforts. If it's not smart enough to understand what it's doing. For example, I use ESLint, and ESLint's got a bunch of really great rules in it, but it's got some rules which are pretty naive. One of those rules has to deal with variable declarations, whether you're allowed to use a variable declaration earlier in the scope. Now, I can clearly say, and we're going to come back to this in our unit on scope, but I can clearly say to you that I wouldn't recommend saying a equals 2 and then var a. That's a terrible usage of that. But that same rule that prevents that also prevents me from saying a equals 2 inside of a function if the var a isn't above the function in the code. That's not at all the same thing, but that tool is not at all smart enough to distinguish those two differences in scoping behavior. And that rule gets in my way instead of helping me. So I don't use that rule. Good news about ESLint is you can write your own rules. I actually just wrote my first ESLint rule plugin. We'll talk about that one a bit later in the course. If we're not talking about nulls and undefineds, but we're talking about strings, numbers, and booleans, there's a prevailing sense here from clauses 4 through 7 that essentially...
if we're not talking about exact. This is double and triple equals. Coercive equality. This coercive equality in null and undefined, which is they are interchangeable. Okay, they are interchangeable from the perspective of the language. From the perspective of the language, they are interchangeable.
And I would claim, but different rule set than you do. I'm sure. Linters are empty values, anything. So, and then undefined, I'd rather deal with null everywhere and pretend as much as possible that undefined doesn't exist, or at least pretend that they're interchangeable.
With this.
JavaScript does make some distinctions between them, such as the default value algorithm. But for the most part, you have the option of treating null and undefined as indistinguishable through coercive equality. So you could do a check like this. You could have a workshop 1 and a workshop 2, and there's a topic property on there. You could be asking of that topic property, if we're not talking about nulls and undefineds, but we're talking about strings, numbers, and booleans. There's a prevailing sense here from clauses 4 through 7 that essentially this algorithm prefers to do numeric coercion.
Numeric coercion.
Numeric comparison.
Numeric comparison.
You'll notice 4 different places it calls the toNumber. It says, if the type X is number, but the other one is string,
if they are not the same type, okay, as it is. If they are not the same type, okay, so if they are not the same type, exactly, if they are not the same type and not undefined or null, the algorithm prefer to do numeric coercion, a numeric conversion. Okay.
Then call toNumber on the string, so I can do a numeric comparison. Same thing in 5, same thing in 6. If one of them's Boolean, then do a toNumber on it and make the comparison. So it prefers to reduce everything down to numbers to make the comparison. Now, you may not like that that's the way the algorithm works. But just by knowing that, it helps you to understand the behaviors and predict the behaviors of the double equals algorithm. That in some cases you thought one thing was happening, but actually an entirely different thing was happening. Instead of two strings getting compared, it's two numbers getting compared. Just knowing in the back of your head, double equals prefers numeric comparison.
Exactly.
That one fact separates you from 99.99% of all JavaScript
Yeah, of
developers,
course.
because they've never even read the spec. So how do we see that playing out? Well, if I have a string and a number, like I am on line 1, that's a number, and on line 2 it's a string. If I do a triple equals, of course, I'm going to have to forcibly make them numbers to do a comparison. They're going to have to be the same type. If I had a triple equals and they were different types, it's always going to fail, right? So I'm going to have to make them numbers. But if I know there can only be number or string, and especially if I know one of them is definitely a number,
if I can know
then
that both
in
of them are
exactly the same way as
number,
I allowed this with the less than sign several slides ago, why not also allow it with the double equals? Why not say that this code on line 4 is more noisy, unnecessarily so, and the abstraction of the double equals is helpful here? It's saying whether they're a number or a string, let's let them compare to each other, and if they're equal, great, and if not, great. But use the abstraction of the tools. I can do this because I designed this particular function or this particular piece of code to restrict the types, to say that the only types here that can be considered for the equality comparison are the string and the number. This would be significantly more complex code if I would allow arrays and objects and booleans and all kinds of other types to come into that comparison. So that case that I keep making is, you can choose to structure your code in such a way that coercion is a useful and obvious system, rather than the complex magic that most people feel.
Exactly.
It brings it back within the realm of reasonable and practical for your code bases. Not just for you, but for all the members of your development team.
Well, like numerical strings in both cases, they could blow up, couldn't they? If it was both numerical strings.
Not just for you, but for all the members of your development team.
Well, like numerical strings in both cases, they could blow up, couldn't they? If it was both numerical strings, like from form.
So if they were both strings, let's go back to thinking about the algorithm. If both of them were strings, what does the algorithm do?
Turns them to numbers.
Nope. If they are both,
a string, let me check at that. I don't know. If both of them are string, okay. Here, if both of them are string, in double equal, right? If the type is number and it's a string, return the result to number, and the string is a type, is a number, result the comparison. If a boolean, return the result of the comparison to number. If a boolean, if they are the same type. No, I get it. If they are the same type, it's gonna do is the strict operator.
both strings, that means they are both of the same type.
Yes,
And what does the algorithm do?
It does the triple equal.
It does the triple equals. So my response to you is, if those strings were literally identical, you'd get true, and otherwise you wouldn't. But that's the same for every string that you do. You couldn't reasonably expect a string that said 3.7 and a string that said 3.07 to equal each other.
I'm talking like about
Those strings aren't equal and those numbers aren't equal.
like a form input that somebody put space in front of it, for example. That would be kind of weird, but if it's the same number but it's space in front.
Again, let's reset back to the context. The double equals is going to allow coercion when the types are different. If you're in a scenario where the types are not different, where the types are the same, then it's not ever going to invoke coercion, ever. If you want some other additional behavior, the thing that you want is not coercion here. The thing you want is string trimming or string formatting or something like that. If you have a case where you have two strings that could have white space on either side and you really only care about the stuff in between, great, there's a thing for that and it's called string trimming. But that isn't coercion. Coercion is when I have a string and a number and I'd like those to be compared to each other. Does that help?
Yeah.
Okay. All right.
And again, remember that if you have now a string with leading characters, what is going to be converted to? And remember, this is they're not going to convert to a string, they're not going to convert to a number. If they are the different types, there is a preference to convert into a number.
So back to our algorithm, the final part, clauses 8 and 9. If you use a double equals with something that's not all right.
Is it if they are different?
So back to our algorithm, the final part, clauses 8 and 9. If you use a double equals with something that's not already a primitive, guess what we invoke our friend toPrimitive We invoke the toPrimitive abstract operation.
We're gonna
We already
try
looked
to
at that. Remember
convert
that's
that into.
the one that calls value of or toString or whatever.
Mm-hmm.
So the double equals, the takeaway here is that double equals only compares primitives. If you use it with something that's not a primitive, what's it going to do?
It's going to try to coerce that into a primitive.
Turn it into a primitive, right?
Mm-hmm.
The only time it does something useful with non-primitives is when they're the exact same type, and then it just does the same value triple
It
equals.
uses the same value triple equals.
Otherwise, it says, listen, the only coercion step I care about right now is getting you to be a primitive. And then we'll reconsider whether the primitives are of the same type or not. Remember how I said earlier in the course that these algorithms are sort of inherently recursive? The double equals operator says, I need to get it to the point where one of these clauses matches. If you give me some scenario where it doesn't match completely, then I'm going to rerun the algorithm over and over and over again until I get it down to two primitives that are of the same type or two primitives that can be coercively equal to each other. And if I never get to that point, guess what? False. They are not equal. So in other words, we would invoke the toPrimitive and get two primitives and then come back to the algorithm with our two primitives and then make the decision accordingly. If you use a double equals between, in this case, a number and an array that holds the number,
is a number.
This is a really terrible idea. You should never write code that compares a primitive to an array like that. But if you did, if for some reason you wrote a function that couldn't control whether somebody passed a number or an array with a number in it, would it work coercively? In this particular case, yes, but should it? Ooh. And why is more important even than does it work? Why would this one work?
What?
Yes, but should it? Ooh. And why is more important even than does it work? Why would this one work?
There are different types, and they're trying to coerce to a number. And because 42, when you coerce that array, or the numberification of an array in this shape is going to convert that into a proper number, therefore it actually works. This is a very interesting question, by the way. This is a very interesting question. This is a very interesting. Double equals walkthrough. Double equals walk through. A very interesting technical interview. Because if you don't know that and you call yourself a senior, it's like...
Why would a number somehow be coercively equal to an array holding that number? And certainly only in the case where that array only has the single number, not if it had multiple numbers, right? So let's invoke that algorithm to see what is actually happening under the covers, to get a sense of what double equals is doing. First, it tries to compare workshop 1 count and workshop 2 count. Mm-hmm. That's the double equals. It turns workshop 1...
Exactly. It turns it tried to coerce that. It say, hey, I have this in two different shapes.
1 count into its primitive form, which is its number. But workshop 2 count is an array. So what it first does is say...
Oh, it's going to convert it into a primitive form.
toPrimitive. What happens to the toPrimitive of an array? It stringifies itself. So then we end up with line 5, 42 double equal to the string 42, right? But that's only because of that weird array stringification that doesn't include the brackets. So it's almost accidentally working here. And only accidentally working because there's only one value in the array. You with me? Now, we have two different types. We have a number and a string. There's two options here. We could either make the number into a string and compare the strings, or make the string into a number and compare the numbers. Which one happens in the algorithm? Two options here, and only accidentally working because there's only one value in the array. You with me? Now, we have two different types. We have a number and a string. There's two options here. We could either make the number into a string and compare the strings, or make the string into a number and compare the numbers.
You make the string into a number.
Which one happens in the algorithm? It prefers numeric comparison.
Comparison.
So the string becomes the number. And notice here, line 6, It does a triple equals because the types are now the same. You follow that line of reasoning? Now, this is obviously a contrived example, but the point here is that even if it works, that doesn't mean you should use it. This is one of those clear examples, I think, where coercion is a very bad thing for us. You should reduce the surface area and not make comparisons between numbers and arrays of numbers. That doesn't even make any sense in programming. And yet, that's where most of our corner cases that we get bitten by are, because we do all of that polymorphic typing stuff. We should never do that. And you shouldn't fix this problem by using triple equals, okay? Most important takeaway here, the fix here is not to use triple equals. Triple equals prevents you from seeing the real problem, which is that you're making a terrible comparison in the first place. What you should do is fix it so that the comparisons that you're making make sense. Yes?
I mean, I understand that you did this to demonstrate a point, but if I would look at code like this, then wouldn't you say that that person has bigger problems than that?
That's exactly my point.
Exactly.
There are bigger problems here.
Yeah,
This is not a...
the bigger problem here is that whoever wrote this code is like, they didn't design this properly here. We need to redesign
You could
this.
go use double equals this.
We need to redesign it, or at least create now or at least instead of redesigning is to extend that. Okay, so let's go to extend that to get the proper value that we want, and therefore like that. So this redesign is something that is not. I prefer to follow the solid principle here. Single responsibility, open to extension, close to modifications. Which means that the code base is going to grow and grow and grow and grow. This is because the way how all of the systems has to deal with the legacy, right? And what's next? The list substitution. So if you're going to create now a child or an object that is descended from a parent must be replaced in its parent as well. And the other is the integration segregation. So instead of having a huge gigantic class, you're going to now create a small interface that can now interact with this huge node or the other nodes. And the dependency inversion. In other words, low-level models should not depend on, or high-level models should not depend on low-level models. Rather in abstractions. Why is this? Because here we can now, with this abstraction, make people that work on the low level focus on what that is important, and people on the high level focus on what is important, and communicate through this abstraction, communicate through this interface, right? So we don't care. People in this area, they don't care about what's happening in the other one. They just care about what is being exposed. They just care about this, similar as a socket. All right. You don't necessarily care about what's going on and how you get that energy. You could figuring out that this is now that the currency that we're getting is AC currency. That depend on where you are. It can be 60 Earths, or 1200 Earths, right? And I really love about that. And that this is something that might come from particularly electricity company, I don't know, Azure, you name it, whatever company, electricity company you have to go with, and all of these intrinsic details you can know, but the only thing that you care about here is that you now can plug your laptop, fridge, or any device to the network and receive energy through that. This is exactly what this dependency inversion means here. So if you're working in a particular stuff and some other are working on particular stuff, especially the low levels, right? So you should rely is on abstraction.
This way. This is what people complain about with double equals, and they're saying that double equals is the problem, and the real problem is that you're making a nonsensical comparison. Double equals isn't the one that's at fault. And triple equals only covers it up. It doesn't fix the real problem. If you make sensible comparisons, like a string representation of a number to the actual number, that's a sensible comparison, and coercion makes complete sense there. But if you compare something to something entirely different, and it accidentally works, that's not sensible. It's not reasonable. I agree with you that the outcome that we see is, why would you do that? But what I don't tend to do is say, JavaScript was poorly designed here. There are historical reasons for why it allowed even the two primitives in a comparison. If I were designing the coercion, I would have done all the other coercions, but not included the two primitives. Because in my opinion, the only kind of non-primitive comparison that should ever be possible is the identity comparison. Coercion with primitives is crazy. But one of the historical reasons for the coercion with primitives is that in the olden days, you did new string, new capital S string, and now you have an object. But you don't think of it as being an object, you think of it as being the primitive. So they allowed that non-primitive to coercively down coerce itself to its primitive equivalent. That's why the algorithm has something like that. Now, I wouldn't write that code, but that's why it's there. So it's hard to say that's a poor design, in my opinion.
I mean, I understand you did the...
You follow that line of reasoning? It stringifies itself. So then we end up with line 5, 42 double equal to the string 42. Right? It tries to compare workshop 1 count and workshop 2 count. That's the double equal. It turns workshop 1 count into its primitive form, which is its number. But workshop 2 count is an array. So what it first does is say toPrimitive. What happens to the toPrimitive of an array? It stringifies itself.
It's a stringify. Exactly. So when you try to go down to the primitive, exactly, it's going to stringify itself. In an object, it is called like that. Okay, when an object is called is the toString and then the other one? Really? I have doubts here. Let me call here toPrimitive. Okay. If result is not an object, okay, if input is an object, it's a hey, exotic prim, simple. If exotic prim is not undefined, then they prefer, okay. It's gonna run is the toString, and then, so the toPrimitive, when you pass now an object, the preference is to coerce that into string. If you can't, then into a number. Okay? In other words, Holy moly, bro. Okay. Exactly. It's a string. It's gonna call that a string. It's gonna coerce that a string first, and therefore.
So then we end up with line 5, 42 bro. Double equal to the string 42, right? But that's only because of that weird array stringification that doesn't include the brackets. So it's almost accidentally working here, and only accidentally working because there's only one value in the array. You with me? Now we have two different types. We have a number and a string. There's two options here. We could either make the number into a string and compare the strings, or make the string into a number and compare the numbers. Which one happens in the algorithm? It prefers
the numberification here.
Numeric comparison. So the string becomes...
Exactly. So when it comes to primitive, if you pass now an object, it prefers now to stringify this. All right? Makes sense. Okay. Okay, if you pass a primitive, well, it's going to now coerce that to that primitive. Interesting. However, this is for coercing a value, okay? But when it comes to now coerce a comparison, okay, or equality here, to check an equality here, it's equality, not comparison. equality here. Now what it's going to do, the algorithm here is to say, hey, if they are the same type, I'm going to call it triple equal. If they are the different type, I'm gonna prefer to coerce that into a number. If it's not, I'm going to check if one of them is an object, all right? And then I'm going to call the toPrimitive, which prefers to convert objects into strings, which in our case, what happened when you stringify this, it gives you now the value 42. And then now, when those values, it's going to check again, when those values now, and it's going to check again here. It's going to check again here. And it's going to check again here. Return the result of the comparison x2 primitive. Exactly. It's going to coerce that. Exactly. It's going to coerce the value. Okay. And try to call that with a primitive. Return the result of the comparison. And it does that in a recursive way.
Is the number. And notice here, line 6, it does a triple equals because the types are now the same. You follow that line of reasoning? Now, this is obviously a contrived example, but the point here is that even if it works, that doesn't mean you should use it. This is one of those clear examples, I think, where coercion is a very bad thing for us. You should reduce the surface area and not make comparisons between numbers and arrays of numbers. That doesn't even make any sense in programming. And yet, that's where most of our corner cases that we get bitten by are, because we do all of that polymorphic typing stuff. We should never do that. And you shouldn't fix this problem by using triple equals, okay? Most important takeaway here, the fix here is not to use triple equals. Triple equals prevents you from seeing the real problem, which is that you're making a terrible comparison in the first place. What you should do is fix it so that the comparisons that you're making make sense. Yes?
I mean, I understand you did this to demonstrate a point, but if I would look at code like this, I mean, wouldn't you say that that person has bigger problems than that?
That's exactly my point.
Yeah.
There are bigger problems here. This is not a, you should go use double equals this way. This is what people complain about with double equals, and they're saying that double equals is the problem, and the real problem is that you're making a nonsensical comparison. Double equals isn't the one that's at fault. And triple equals only covers it up. It doesn't fix the real problem. If you make sensible comparisons, like a string representation of a number to the actual number, that's a sensible comparison, and coercion makes complete sense there. But if you compare something to something entirely different, and it accidentally works, that's not sensible. It's not reasonable. I agree with you that the outcome that we see is, why would you do that? But what I don't tend to do is say, JavaScript was poorly designed here. There are historical reasons for why it allowed even the two primitives in a comparison. If I were designing the coercion, I would have done all the other coercions, but not included the two primitives. Because in my opinion, the only kind of non-primitive comparison that should ever be possible is the identity comparison. Coercion with primitives is crazy. But one of the historical reasons for the coercion with primitives is that in the olden days, you did new string, new capital S string, and now you have an object. But you don't think of it as being an object, you think of it as being the primitive. So they allowed that non-primitive to coercively down coerce itself to its primitive equivalent. That's why the algorithm has something like that. I wouldn't write that code, but that's why it's there. So it's hard to say that's a poor design, in my opinion.
Holy moly, bro.
Let me summarize how double equals works. This is a summary of the algorithm. You can read the algorithm, but it's a summary. If the types are the same, it's just going to use triple equals.
Exactly.
If both of them are null or undefined, they are equal. If there are non-primitives involved in the comparison, they are always going to become primitive first. And then once you have
if they are non-primitive,
both of them are null or undefined. They are equal. If there are non-primitives involved in the comparison, they are always going to become primitive first. And then once you have primitives, prefer toNumber. And I'm just optimistic enough to believe that every developer, from the junior developer with 2 weeks of experience in JavaScript up to the experienced developer with 20 plus years, can understand a fairly straightforward system like that. And by understanding it, avoid the places where it can be problematic. So what are those problematic cases? Many of these are ones we've already seen, but let's talk about the corner cases. We got to talk about them 20 plus years. So what are those problematic cases? Many of these are ones we've already seen, but let's talk about the corner cases. We got to talk about them so that we can avoid them. Some of you have undoubtedly seen the WAP video I've referred to multiple times, and one of the famous
double equals summary. Doubles equals summary. They're not gonna change that, bro. If they change that, they're gonna break that. If they change that, they're gonna break the internet. Corner cases with booleans. Double equal corner cases booleans, corner cases summary.
Things in the WAP video was, how could something like an empty array somehow be coercively equal to the negation of itself? And on its surface, the way that problem is constructed, it seems like a clear argument against JavaScript and a clear argument against the double equals. But this is not as it seems. This is not as it appears, because this construct is a false construct to begin with. You would never, under any circumstances, compare a value to the negation of itself. Ever. That's just never going to happen in your programs. So we went and looked for this artificial scenario that would never happen in real code, and then said this whole mechanism is broken because this one weird corner case doesn't behave sensibly. Under what circumstances would you ever have an array and then try to compare it to the negation of the array? The negation of any array, not just itself, of any array. That would never sensibly occur. You would never design code like that. Nevertheless, let's explain how it works. It's going to use the exact same stuff I already taught you. If I had two arrays, and for some strange reason I tried to compare one array to the negation of itself, compare that in your mind to the more appropriate comparison, which is to say, I want to check to see if they're not the same array. That's the not equals. Those might look like the same thing, but these are entirely different approaches. One is saying, I want to see if it is coercively equal to its negation, and the other one is saying, I want to see if it is not coercively equal. Those are entirely different beasts. Line 8 is what you would write in code sensibly. Line 4, the WAP video source, essentially, is what you would never write in code. But let's just indulge it for a moment. To explain the algorithm, how we're going to explain that line 4 allows it and also line 8 allows it. How is it possible that both of those can be true? Well, here's the algorithm in play. Number one, we start with the workshop 1 students not equal to the negation of the workshop 2 students.
Exactly.
What we have to do is reduce workshop 1 students to its value, which is an array, and then negate.
And then negate that or coerce that.
It's workshop 2 students. Workshop 2 students is an array, which is truthy. So if we negate it, it becomes
a false.
Line 5, it becomes false, right? Now, we have a...
Why does it become false? Because you are now doing this type coercion, which means that, hey, I'm going to invoke this array, and I'm going to transform it into a primitive. This primitive is, if this is an object, I'm going to convert that into an empty string, because that's what it's doing here. It's like, hey, I'm going to convert this value here, and this value, holy moly, and this value here, okay, and this value that I'm coercing here, you say, exactly. Let's go to walk through this. So I have this 2 array, right? And I'm gonna coerce that. So because the double equal here, what you're gonna do is to first evaluate this expression and say, hey, I'm going to coerce this. I'm gonna negate this. What it's doing is the operator, like that, is gonna coerce that into a boolean, right? Or you can say is operators, exactly. Unary operators. Not exactly. Unary operators, right? What the fuck is this? Unary operators. Delete type of void relationship. Oh my god, for real? Logical operators, like this. So logical complement negation operator takes true or to falsy values and vice versa. So in other words, if you take a look now at the here, say operators, okay, or binary logical operators, logical operators, what it's doing is, because I prefers to so here logical negator operator, what it say is to say, hey, I'm going to evaluate that and I'm going to coerce that into a boolean. See? Things started to make a lot of sense here. The old value to b, to boolean, okay, and I'm gonna get that value. And what's happened when you try to coerce objects to a boolean? All right. Remember, if those booleans are now are not falsy values, aka it's a true value, which is in our case with the example here, okay, this is the example that I want to make here. This is just an example that I want to make here. Corner cases. And then you get this, right? And then we say things like this. Say this is equal to this. All right. And, well, because here we want to evaluate this, what will happen? So this is going to the negate operator is I'm going to use the to boolean operator, okay, which I'm going to coerce this value, whatever value I'm going to coerce this type into a boolean. So if this is an empty string, it becomes a true, and therefore that value, I'm going to negate that. I'm going to make that false. Okay. So this becomes false. So this becomes a boolean here. So this becomes a boolean. Okay. So this becomes a boolean. And since that becomes a boolean, and when you have these two different types here, as an array and a boolean value, it's going to prefer to do a number coercion. So false becomes a 0 and an empty array becomes now a 0. Therefore, 0 is equal to 0. Now they are on the same type. Oh, well, exactly. It's because it's going to do this first, and then the coercion to this, and trying to boil down into a primitive. It's interesting because both of these are trying. Okay, this is what's going on behind with the double equalists. It's trying to coerce into primitive any object. Okay, but first it's going to evaluate this expression. So JavaScript say I'm going to evaluate this expression and this another expression. Okay, I'm going to evaluate is this and this. I'm going to take those value, coerce that. If one of them is primitive, I want to coerce. If one of them is an object, I want to coerce into a primitive. And if this is an object, I prefer to convert it into a string. So this becomes now an empty value, all right? And this empty value that is will be now the result of this expression, which I'm going to this negate operator say, I'm gonna take this value, I'm gonna coerce it to Boolean, and the Boolean value of this is true, all right? I'm gonna coerce that. Let me actually write this down. So workshop 2 is going to say, hey, what is the value of this into a Boolean? It is true. So I'm going to negate that. Okay, I'm going to negate that. And this is the result of this. So I'm going to now coerce this value here. I'm going to call this abstract operation. And if this abstract operation is an object, then I'm going to call the toPrimitive, which has a preference to call the to string, which I'm going to stringify that. And the stringification of this is now an empty an empty array or an empty string. All right. I am right with this. So if I want to transform into a string, yes, this is now this becomes now a empty string. That's right. This becomes now an empty string. Since both of things are the different types, which is in our case, this becomes now true. This is false. Since both of things are from different types, I will prefer to do is a numeric coercion, which means is empty string becomes 0 and false becomes 0. Okay, therefore both of them are therefore both of them are like that. Exactly. And then this is going to coerce that into a 0. And since both of them are the same type, therefore it's going to call that. But this is what happened first here. I don't know. A numeric coercion. Holy fuck. That's interesting. The walk through example. Exactly. The double equal summary here is the types are the same, If the type are the same, do this. If this is null or undefined, so they're equal, so they're true. If this is a non-primitive, I'm gonna call it toPrimitive with the hint of a string. Okay. And then if not, I'm going to prefer, if they're the different types, after that I'm going to prefer now toNumber here. Holy moly, bro.
Workshop 2 student.
This is what happened with the one. Okay, example 1. From the workshop students, exactly. So workshop 1 student is equal to workshop 2 student. Okay. Exact. And the other is the walkthrough. Wait, what? And the other is a walkthrough student from this. So this operator, what it's doing is completely different stuff, bro. You can have is the operator here. Comparison, the different logical operators, relational operators here, equality operators. But this is expressions. Abstract operations here, type testing. But statements and declaration. What am I looking for? Is this, which is which is this ECMAScript data types, language type, abstract operations, syntax, executing ordinary and exotic behaviors. Left hand relational comparison. Assignment, exactly, assignment. But this is not an assignment. Yeah, this is a this is not an assignment here. Equality operators. Invoke by evaluation semantics. Equality operators here. There you got it. Here you got it. Okay, runtime semantic evaluation. Equality expression and relational expression. If the left reference be evaluated as an equality expression, get the value of the right side, get the value of them, and then run a loosely equal expression here. So get the value of this and get the value of the, so evaluating is the left and then the right and get the value. Okay, evaluating is the left and the right. Evaluating is the left and the right first. So in other words, it say, hey, this is an empty array. Okay, This is an empty array. And I'm going to evaluate the other one, which is an empty array. Okay. Like so. Since both of these are empty arrays, all right, from this value, if both of things are empty arrays, then I'm gonna call isLooselyCouple and say, hey, if they are the same type, I'm going to do now is, so if they are the same type, I'm gonna do is now, which is this. If this is true, return false. Otherwise, exactly, and it is calling that. If they are the same type, which means it's going to call triple equals in objects, and when it comes to convert that into an object, okay, which mean is it's going to call the is loosely equal. If they're the same type, which is x and g, return is strictly equal. If they are the same type, okay, like this, if they are the same type, which are objects, return true. So because this is going to return true, okay, by calling that same type, by calling the triple or this abstract operation called is a strict equal, okay, by calling this abstract operation is a strict equal, and they check that both of those objects are the same type, okay, return true, and it say if the same type is going to return false. Therefore, it's going to return false. Therefore, the evaluation of this will be false or true. Will be true. So what happened here is that it's calling this. This operator says, I'm going to call both of them. I'm going to call this the loosely equal. They're going to be compared by its type. If they are the same type, which is in our case, both of things are objects, okay? If they are the same type, I'm going to call this a strict equality, which say, hey, if both of them are the same types, return false. And in our case, since we are negating this, all right, this is the value that we return after we call the strict equal for that is false. And since we want is to negate that, we're going to return true for that. So in other words, if you compare these two values here, okay, like this is different from this, and it gives you now true. Holy moly.
Students. Workshop 2 students is an array, which is truthy. So if we negate it, it becomes line 5, it becomes false, right? Now, we have a non-primitive compared to a primitive. So we need to turn that non-primitive into a primitive. We need to turn the array into a primitive, and what does it become? It becomes the empty string. So now we have an empty string compared to false. We have two primitives, but they're not of the same type. The algorithm prefers that they both become numbers.
Exactly. The algorithm prefers that both of them become.
So this one becomes a number, which it shouldn't, but it does become the number 0 instead of nan. And this one needs to become a number as well, and now 0 is equal to 0. Okay? The algorithm is sensibly applied, but it's on a bogus corner case that would never actually happen in your code. So it's not an effective argument against this mechanism. It makes for great videos and great headlines, but it's not a rational argument. The second one is much more rational, because if we look at the equivalent of the not equals, it's basically like the negation of the coercive equality. So we can ask ourselves, does it make sense for Workshop 1
Exactly,
students
the
to be
negation for
coercively
that when you
compared
look at this
to Workshop
spec,
2
you don't read the
students?
spec.
Well, since they're both arrays, then what we're effectively doing is asking an identity question. We're saying, are they not the same identity? Which is a totally valid thing for you to ask in your program. And it would work identically to if you use the triple equals version of this. It's a rational thing, and it has no difference in the rational case between double equals and triple equals. Let's talk about double equals specifically with Booleans. This is another one of those really evil corner cases that you shouldn't do. This is something that you do a lot in code, and it's something you should definitely not do. It's something you do because you're used to doing this in other languages, and here it's going to get you into trouble. Okay? If you want to check, if you want to allow the Boolean coercion of an array to be true, in other words, you want to say it's truthy sort of construct, that is something that I'm okay with. Some people are not okay with that. But let's say that you do for the moment. There's one way of doing it, which is just to do an if statement. Allow the if statement to invoke the toBoolean operation on the array, which in this case is a lookup that says the array is not on the table, so therefore it's true. That's a perfectly rational, implicit toBoolean coercion.
Exactly.
But if you try to get more clever and tricky with it and say, well, if it's truthy, then maybe what I ought to do is do a double equals with true. Well, now all of a sudden it doesn't work. And by the way, it wouldn't work with
because now it's going to coerce that two different values. All right. Since they are different, one of them is going to be coerced to
triple equals either. Because the comparison with a Boolean to an array is going to go through a bunch of those corner cases, which we've already identified, and we're about to re-identify. And also, it's not going to be equal, it's going to be equal to false. So now you're going to get the backwards of what you would intuitively expect. You think this thing is truthy. It is not double equal to true, but it is double equal to false. There's no question that this is a gotcha. But before I even explain the gotcha, my answer to this is don't ever do a double, or even in that case if you can avoid triple, but definitely never do a double equals with true or a double equals with false. Because there's no scenario where you need to do double equals with true or double equals with false when you could just do the toBoolean implicitly. There's no case where that or that is better. And there's a bunch of cases where it's worse, like this one. Okay? So let's explain how the double equals to true fails, but the double equals to false works. Same steps, same algorithm. We start with the top one. Of course, if workshop students, we just do a toBoolean on it, line 4.
Exactly.
We check for the Boolean on it, and if it
Boolean
matches, great. In this case, it does, so we run that code branch.
We look up for the table.
But what happens when we're trying to double equal it with true? Well,
Exactly. What we double equal to, which is the loosely coupled, all right, is going to coerce that into empty string. Since they are now two different values, this is one of the root. Okay, this is when the root of all evil is with empty string. Since it's going to call the toPrimitive, and this primitive of objects is now a stringification of them, which is in the case of array are now 0. Okay, it's an empty string. Sorry. Since both of them are different type, it's going to coerce that into a number, all right, which is, hey, what is the numberification of an empty string? 0. And the numberification of an empty or a true value? 1. And therefore
we have a non-primitive, which needs to become a primitive, so it becomes empty string. We have a empty string and a true. These are not the same type, so they need to both become numbers. One of them becomes 0, which should have been nan. The other one becomes 1, and those two numbers are definitely not equal. So we don't run that code branch. In the other code branch, we do the exact same thing. We start off with workshop students equals false. We get to a string equals false, which becomes a 0 compared to a 0, and those zeros are equal to true. That's a nonsensical outcome to what was a nonsensical construct. You don't need to do double equals to true or double equals to false. Allow the toBoolean to happen implicitly. So yet again, what I'm saying is that implicit is sometimes much better than explicit. In this case, the implicit doesn't have the gotcha, and the explicit does.
This is maybe too broad a question or too generic, but are there cases where you would go a step further and rather than running, if workshop students, you would check like if and then a method on workshop students, checking the presence of, are there cases where you would go a step further and rather than running, if workshop students, you would check like if and then a method on workshop students, checking the presence of, dot length to make sure it's a string or an array, or, checking other type specific.
So the scenario of this construct is I only want to know whether it's set or not. And I know that it can either be unset or it can be set to an array. That was, the mental construct of the scenario. So that would have been obvious by the rest of the surrounding code, or at least hopefully obvious from the rest of the surrounding code. If we didn't know that, if we knew that it could be unset or it could be set, and it could be set to a variety of different things, maybe an array, maybe an object, maybe a string, then we would want to do some sort of deeper checking than just the two-Boolean coercion. That might be the first step to check that it is actually set, and then the next check is to check something about its identity. And there's various ways that you could check it. You could use a type of operator, if that was appropriate. You could do what you're referring to, which is called duck typing, check to see if a method is on it. You could do an actual utility like array.isArray to check if it's an array. There's a variety of other things that you might want to do if you cared to specifically know it was an array. But the setup I have here is that we would already know it's an array because we already see line 1. It could either be set or it can be an array, and it can't be anything else in between. Does that make sense?
Yeah, and I guess my question is if you would typically advise against packing in like duck typing into line 3 into that check, trying to combine both.
No, that's not what I'm saying. What I'm saying is I would do those if for some reason I couldn't restrict myself to know that it's either unset or an array. I would prefer a smaller surface area with fewer necessary checks. I would prefer to design this code so that it's not so polymorphic. It's either unset entirely or it's an array. But if for some reason I couldn't design my code in that way, then I would put those extra checks into the if statement. Does that help?
Yeah, that's great.
Okay.
Okay.
A takeaway, or a way to summarize how to avoid these corner cases with the double equals. These are a set of guidelines that I think you can use. You can use double equals, but avoid it in these particular scenarios. Number 1, avoid the double equals when either side of them can be a 0 or an empty string, or even one of those strings with only white space in it. Don't use double equals in those cases. There's just a lot of corner cases that you might get bitten by. Some people say, well, I can't know. Okay. But is there any way for you to restructure your code so you can? Because I think that's better. That leads to better code, regardless of whether you like double equals or not. But let's say you can't. Well, then another check that you should ask, or to avoid the double equals, don't use it with non-primitives. I don't even use it with the identity comparison on them, even though I know it works. But just to be super safe, I don't use it with primitives at all.
Yeah,
so if I was really trying to check, is this array, is this reference to the array the same as this reference to the array, I'm not going to use the double equals, even though it would work in that one specific scenario. It's close enough to the edge that it's not working.
Because if I want to compare the value later on,
or my preference.
okay?
So don't use the double equals when they're non-primitives. Only use it for coercion among the primitives.
Is this not empty or not?
And definitely don't use double equals to true or double equals to false. Essentially, just allow the two-Boolean to happen, which is the better outcome anyway. Or if you really can't allow that, if it really has to be exactly true or exactly false, which sometimes it does, then use triple equals. This is a relatively short list, and I would make the case that any developer that cared to learn about these systems could learn this list and effectively do so. Effectively communicate in their code that they're avoiding these problems.
No, okay. Absolutely, man.
So let me bring this down to a case that I want to make. And this is much more of a direct case than I've ever made before about this topic. Most of the time prior to this point, my essential takeaway or my essential message to people was double equals and triple equals can coexist in your code, and you can make choices. You don't have to avoid the double equals. I'm going to make a stronger argument at this point. The stronger argument that you should prefer double equals in all possible places. And I know that's going to shock a few people, but you're going to have an open mind to listen to this argument. Taking everything in whole, in totality that we've talked about together, including the fact that it is my claim that code that understands types is better code regardless of the choice. Within that context, I think I can make the case that double equals is preferable to triple equals. So, knowing that those types is better, knowing the types is always better than not knowing them. The uncertainty of code is what makes code hard to read. It makes code susceptible to bugs. Some people respond to that problem of not knowing their types by saying, I need to change my coding style to use static typing, like TypeScript and the others. We're going to talk about TypeScript in just a moment. But I don't think that that is the only response to this problem. There's another response to this problem. So, double equals is not about comparisons with unknown types. That's not what it's for, and that's not what you should use it for. That is the opposite of what most people claim. Most people claim that they use double equals when they don't know the types, and then they fall into these bugs. And I'm saying, don't use it in that scenario at all. Never use the double equals when you don't know the types.
Of
Ever.
course. Not at all.
Only use the double equals when you know the types. And as I said, you should strive to know the types in your comparisons as much as possible. It's about comparisons with known types, and optionally, if you like to have coercions. Maybe all of your comparisons, you know the types, and maybe all of those types are always equal, and you never use coercion, and still in that scenario, double equals is preferable. But maybe some of the times you want to take advantage of coercion, and then double equals is essentially your only option.
Optionally, with conversion or help.
So let's dig into the nuance here, because I know some of you are not going to believe me just right off the bat. Okay, let's dig into the nuance here. If you know the types in a comparison, and I think you should, if you know the types in a comparison, and both of the types are the same, then we already know that double equals is triple equal, is identical to triple equal. We already know they're interchangeable in the case where you know them and they are the same. So you're saying, yeah, but that doesn't mean that I ought to use it. My claim is using triple equals is unnecessary in that scenario, and you should prefer the shorter double equals. That is not just about using one fewer character.
Exactly.
Okay? Some of you know that TypeScript does a lot of work, even if you don't do any types at all. Here I have no types annotated whatsoever, and it still does a bunch of inference, type inference.
Exactly.
And in this particular case, what the error is telling me is I should not use a triple equals because the types are different, and this will always be false.
Mm-hmm.
Now, I don't know about you, but I find that to be a particularly useful error message. It is telling me, don't do something stupid that would always fail. 100% guaranteed to fail, right? It knows that it'll fail, and it tells me, don't do it unnecessarily. My claim is that if we find that to be reasonable, then the counterpositive is also reasonable. If it is pointless to use it when the types don't match, it is unnecessary to use it when the types do match. If we like for our linter to complain when it would be pointless, then we ought to have a linter that complains when it's unnecessary. So if you know the types in a comparison, and they're different, this is where things get interesting. Because supposedly, using the triple equals is protecting you and saving you. But if you know the types and you know them to be different, a single triple equals will always fail, which is the whole reason for that TypeScript rule we just talked about. It would definitely be broken. You with me? So your only two options in that case, if you know the types and they don't match, you have one of two options. You can either not do the comparison, or you can use double equals.
Or you can do...
Those are your only two options. And if you know the types in a comparison, and they're different, the only equivalent to a single double equals would be two or more triple equals. You cannot have a triple equals and a double equals be equivalent when the types are different. That is impossible. So, you cannot have a triple equals and a double equals be equivalent when the types are different. That is impossible. So, if you have a scenario where you could use one double equals, or you could use two or more triple equals, guess which one is going to be slower? The two triple equals. It is faster to let JavaScript do the coercion than it is for you to make a bunch of explicit ones. And it gets even worse if you have to do 3 or 4, depending upon the complexity of the coercion. Now, I say slower in air quotes, because we're talking about microseconds. But it is absolutely not possible for triple equals to be faster in this scenario. In the best possible scenario, it's equal, and actually in reality, it's just a tiny bit slower to list them out multiple times. Now, I'm not making the case that on performance alone that's an argument, because the microsecond difference is not that relevant. But this is part of the larger case that triple equals is not somehow superior to double equals. Many people have said triple equals is faster because it doesn't coerce. That's an apples to oranges comparison, because you're saying one triple equals is faster than one double equals, and they're not equivalent. If you actually looked at an apples to apples, two triple equals is always going to be a little bit slower than one double equals. So, if you're in this scenario where you could do two triple equals or 3 or 4, or you could do one double equals, I say you should prefer the faster of the two, which is the single double equals. Part of the argument, certainly not the entirety of the argument. And finally, if the types are different, 2 or more or what the comparisons, that's what you would use as 2 or more of the triple equals. My claim is that it's distracting the reader with unnecessary type information, like in the null undefined case, for example. In the null undefined case, you're distracting the reader that there's these 2 different empty values and they sort of have weird, quirky differences. That's not necessary for the reader to see in most cases. In most cases, you're distracting them by listing it out explicitly, and what you ought to use is the more properly abstracted coercion that is cleaner with the double equals. Now remember, this is if you know the types, right? I'm only making these claims if you know the types. And by know the types, I mean that it is obvious to the reader of the code what the types will be. So what about, oh, sorry, there's one more. The summary slide, of course. This is if you know the types. So in summary, whether the types match or not, double equals is the more sensible choice when you know the types, okay? When you know the types, double equals is the more sensible choice. So let's look at the other side. In those cases where you don't know the types. If you do not know the types, that means you don't fully understand the code. That may be a necessary requirement. It is not possible to guarantee 100% you always know the types in the entire system. That's not reasonable and rational. So I recognize that there will be times when comparisons happen and there's some uncertainty. My claim is that that should be a rarity rather than the status quo. But what it does mean, whether it's a rarity or the status quo, is that that part of the code is harder to understand as a result of that uncertainty. So not knowing the types means that you don't fully understand that code. The best response is to refactor it so that you can know the types, if possible. If you don't know the types, and that uncertainty of knowing just has to be dealt, then at least make sure that that is obvious to the reader. Make sure that it is obvious to the reader that there is some uncertainty here. Put a code comment. Structure it in such a way that the reader doesn't have a false sense of security. They think they know what's happening, and actually it's uncertain. It should be super obvious that it's uncertain in whatever possible way you can. Because again, we're trying to communicate our intent. My intent here is to tell you that it's uncertain, just so you know. Beware, there are dragons, right? That's what we want to do with our code. So it should be obvious to the reader. And the most obvious signal you can use about that uncertainty is the triple equals. If you followed what I argued in the first set of clauses, which is that the double equals is preferable when you know the types, then the usage of triple equals should be reserved for the cases where you don't know the types. So that it signals to the reader, I don't know the types, I'm trying to protect myself. It should jump out. The reader should see, oh, there's a triple equals here. That means there's some uncertainty of the types. And we need to restrict ourselves so we don't run into a corner case. Also, I would say that not knowing the types is equivalent to assuming that type conversion or type coercion will occur. It's equivalent to assuming that, because if you don't know the types, the worst case scenario is that they will not match, and that they will not match in some weird way that invokes some weird corner case of coercion. You need to assume the worst case. So not knowing the types is equivalent to that worst case coercion. And the only sensible response to that, the only safe response to that, is protect yourself from that with a triple equals. In summary, if you can't or won't use a style where you can know and have obvious types, the only thing that is sensible and reasonable is for you to use the triple equals.
If you can or won't use known and obvious type, triple equal is the only reasonable choice.
This isn't meant to be an attack against you if you use triple equals. I'm just trying to reframe this discussion in a way that actually moves the discussion forward rather than this sort of religious debate of, well, you know, this one book said never use it and I've never even considered anything else. I'm actually trying to make a rational set of analysis here to come to some real conclusion, not just the thing that one guy said, okay? And you can test my analysis. If you don't agree with my rationale, that's okay. But I'm laying out this case so that you can test the rationale. And I would say this, even in that scenario, where every place that you would use a triple equals would be the same, it would be equivalent to a double equals. And so you say, you know what, we just want the simpler thing. We want to use triple equals everywhere because that's what our linter says. What you're actually doing is sending the wrong semantic signal to a reader of your code, which is, I'm protecting myself in all these cases because I don't know anything about the types. And that is not communicating what you ought to communicate to future readers of the code. Future readers of the code that see the semantic signal, I don't know about the types, so I have to fall back to some triple equals to protect myself. Those future readers of the code are much more likely to rewrite your code because they don't understand it. They're going to do what you should have done the first time. they're going to refactor it to where the types are known. Uncertainty is not a good thing for your code bases. So in summary, making your types known and obvious just leads to better code. There's no argument that can be made to the contrary. Knowing the types leads to better code. And if the types are known, double equals is always best. In every scenario, double equals is best when the types are known. And in any scenario where you can't, you should fall back to triple equals. I'm fully aware that that case is quite controversial. And it's unlikely that any of you are convinced at the moment by that discussion. But what I would really like to ask you is to go back and think about it. Go back and test this rationale and test it against your code. Ask yourself if you really are writing better code that is more clearly communicating its intent by simply using triple equals everywhere. I can't make those decisions for you, but I think I've made the most solid case that I can for why this should be reanalyzed. Let's dig in a bit on this topic of equality, because there's a lot of meat that we just went over in terms of equality. So we want to have a whole exercise dedicated to this.
Holy moly. That'll be all for this video. Take care. Bye-bye.